Hello everybody, thanks so much for joining me today. This is going to be the recorded condensed version of the stream for the Harvard CS50X 2025 Week 7 on SQL or SQL. This stream is broken down into two parts as I watch these on 2 separate days. Please consider joining me live every day at 7 p.m. PST where I watch these lectures live and do other coursework related to computer science. Enjoy.
All right, this is CS50, and this is our week on SQL, or SQL, for Structured Query Language, which is a programming language specifically for talking to databases. Now, over the course of this lecture, what we're going to do is solve some problems in new and different ways by transitioning from that other language, Python, which it turns out is very multi-purpose. And indeed, this is thematic with Python in that you can do so many things with it, but it turns out there's certain things you might want to do in computing that maybe aren't ideal for a language like Python, let alone a language like C. And so you might want a more specialized language that makes it easier for you to get real work done. And indeed, this has been true over the past several weeks. We started with Scratch, we transitioned to C, we then transitioned to Python. And there's actually a lot of overlap in those languages in what you can do. They're not perfectly complementary. I can't imagine doing some of the things we did in Scratch using C. But what we will see today, no pun intended, is that using a domain-specific language, something specific to databases in this case, you can actually save a lot of time and express yourself a lot more readily with a lot fewer lines of code than something like Python allows. But before we do that, I dare say it would be ideal if we have some data that we can play with, so we have data to put into a database. And let me propose that we go ahead and collect some live data here. So if you'd like to go to this URL here that's on your screen, if you're on a laptop or desktop, or if you simply have your phone in front of you, feel free to scan this code here, which will lead you to a Google form via which we're going to collect some information from everyone here. I'll go ahead and in just a moment transition to just a screenshot of what everyone here is seeing, because if you're watching this on demand thereafter, the form probably won't still be open because we can't take data from the future into account today. But what we'll have here is a Google form via which we're going to collect some information from everyone here in the room virtually. And this form asks 2 questions. One, it asks, what's your favorite language? The options for now being Scratch, C, and Python. And it also asks, what's your favorite problem from recent problem sets? So go ahead, take a moment, and fill out that form. And in just a moment, we'll see that these responses are being gradually collected. Not in the context of the Google form per se, but in a more useful format for today's purposes, that of a Google spreadsheet. In fact, let me switch over to my other laptop here where I have full screened all of the responses as they are coming in. You'll see that all of them are timestamped for a particular day and time on which we actually recorded this here session. And you'll see 2 columns, one for people's preferred language and one for people's preferred problem. You'll see that a few folks sort of jumped the gun a few hours even before class began, but that's great, all the more enthusiastic. But as I scroll down here, you'll see there's a lot of data coming in, a couple of hundred responses already. And so let's go ahead and use this data now to actually manipulate it, to search it, to sort it, and actually ask questions about this here data. And in order to do this, what I think we're going to do is first talk about what are called flat file databases. A flat file database is kind of the simplest type of database in the world, whereby you just use a text file, a file in which you can store maybe some rows and columns. But that's actually not really possible in text files alone, because of course in text files you literally just have text. So you can put any characters you want on the screen. You can maybe have different lines of or different rows of text. But we probably ideally need some way of delineating the data that's inside of that file. And one of the most common ways to do this is via a file called CSV, comma separated values, which is a file format via which we can store really a simplistic database in purely an ASCII or really a Unicode file. And what this means is that all of your data in a CSV file is stored row by row by row, or technically line by line by line. So each entry has a line of its own. But for the notion of columns, you can do this in a number of ways. But the simplest way, as in the CSV format, is to just put a comma in between the values that you are actually collecting. And then, so long as you're using software like a spreadsheet or maybe Python code or something else altogether, you can tell that software to interpret those commas as really delineating where one column ends and the next column actually begins. So it's a nice lightweight format using a very familiar tool like a text editor to actually store some data that we might care about. And in fact, what's nice about collecting data via forms nowadays, whether it's with Google Forms or whether it's with Office 365 or the like, is that you can actually export all of the data ultimately in exactly this format, CSV. So in fact, let me go back over to my actual browser here, and you'll see that we indeed have some more data, some more rows that have come in over time here. And if I go up to the very top of the screen and drop down the menu here, you'll see that under the File menu, under the Download submenu, I can actually download this data set in a bunch of different formats. Microsoft Excel, with which many of you are probably familiar, PDF, although that really won't lend itself to manipulating it very easily with code, HTML if I want to make a web page out of it. But you'll notice at the bottom, there's actually a couple of options, one of which we've talked about already, namely CSV, for comma-separated values. There is an alternative called tab-separated values, which also is a convention too, whereby to delineate columns, you simply hit the tab key to kind of shift the data over. But I dare say CSV is probably a little more common, if only because a lot of text editing programs nowadays automatically convert tabs to spaces. Indeed, CS50.dev and VS Code, as configured, does exactly that. So CSV is a little more robust. So I'm going to go ahead and click on comma-separated values. That's going to drop a file into my Downloads folder on my computer. I'm going to go over to VS Code now, minimize my window for just a moment, and then open up my File Explorer, which initially has nothing in it for today. I'm going to go into my macOS Downloads folder and simply drag this file over to the Explorer to essentially upload the file to my account. I'm going to go ahead now and hide my Explorer, maximize my window again, and hide my terminal window, and you'll see exactly that same data here, but clearly in textual format. Now, the file is by default called favorites-form-responses1.csv, but let me actually simplify that just to make my life easier. Let me open up my terminal window, and the command, recall, for renaming a file can be mv for move. And I'm going to rename that file favorites-formresponses.csv to more simply favorites.csv. Now let's go ahead and open up that same exact file, but under a different name now, and we'll see these rows and columns. But it's not quite as pretty as Excel or Google Sheets or Apple Numbers would be. We have to look a little harder for each of the commas, and indeed, in each of these columns, in each of these lines of text, rather, we have commas delineating one piece of data from another. But the very first row in this file is a little different. The first row is actually the headers of the columns that we saw visually in Google Sheets a little bit ago. And so that's actually indicative, that's actually pretty common in CSV files, whereby the first row and only the first row is somehow special. And most software will interpret that first row as being special, as really describing the data or the attributes or the records within each of those columns that follow line by line. Now, there is one curiosity here. Notice that the first line, really the second line after the header file, has three values: the timestamp at which the form was submitted, comma, the language that that person found to be their favorite, comma, and the problem set that that person found to be their favorite. But notice here, line 3 in the file, there's actually 3 commas instead of 2, even though there's still just 3 values. Why do we have the quotes around the name of this problem set, Hello World, whereas Scratch did not have a value, Tiedemann did not have a value, Mario did not have a value? Because we named that problem set hello, comma, world, we need to make sure that the value is essentially escaped somehow, as with double quotes in this case here, to make clear to any software that's processing this data, be it again Google Sheets or Microsoft Excel or Apple Numbers or my own Python code ultimately, that there is something special going on in that string, and that comma should not be confused with the other commas which actually have meaning to delineate those columns. So what can I actually go about doing with this file? Well, let's actually go ahead and start answering some questions about the data here. I realized that not everyone got their response in from time because I downloaded the file just a couple of minutes ago, but I think this is enough data for us to play with. So let me reopen my terminal window here and clear my terminal. And why don't we go ahead and write a program in Python for now that simply iterates over this data toward an end of doing something interesting with it ultimately. Let me go ahead and create a program called favorites.py. And in this file, let's go ahead and do this. First, I'm going to go ahead and import a package called CSV. It turns out in Python there's built-in support for CSV files, which is going to save me a huge amount of time because I'm not going to have to figure out how to open a file and iterate over every line and break on all of the commas and somehow load it into memory. The CSV module is going to do a lot of this for me. So I'm going to go ahead and say with open, quote unquote, favorites.csv, comma, quote unquote r, and this is going to allow me to open a file called favorites.csv, which is the shorter name. I gave that same file a moment ago. Quote unquote r means open it in read mode, and I'm going to give this a variable name of file, just so that I know how to refer to this file once it's open in memory. Then if I want to read this file line by line, it turns out thanks to this Python package called CSV, I can do this pretty easily. For instance, I'm going to create a variable called reader. I'm going to set that equal to the return value of csv.reader. So inside of the CSV package, there is a function called reader that is going to give me exactly that conceptually, some kind of object in the computer's memory that knows how to read CSV files. I have to tell it what file to read, so I'm going to pass in that same variable that I just got back from opening the CSV file itself. Now, for the moment, I want to go ahead and iterate over all of these rows. So for each row in that reader, and this is wonderfully useful Python syntax for just iterating line by line over this so-called reader, let's just go ahead and do something simple like print out the second column we see in that file. So recall that these columns are going to be 0 indexed as our Python lists. So 0 would be the timestamp, and I don't really care about that. 1 is going to be the favorite language, and 2 is going to be the favorite problem among our problem sets. Let me go down now into my terminal window, run Python of favorites.py, cross my fingers as always, and voila, I seem to get out very quickly on the screen a list of all of the languages in that column. But if I scroll back to where I just ran that command, let's go up and up and up and up, all the way to that output, which is a ways away now, though I can clearly see visually a theme here among the most popular language in the group today. Let me keep scrolling back, and oops, there it is, my command that I ran earlier. There's one anomaly here. The options on that form were Scratch, C, and Python, and yet it would seem, based on my output here, that someone's favorite language is language. But that's a bit of a red herring, because recall that in favorites.csv, that first row was important. That first row had timestamp, capital T, because that's how Google does it, language in lowercase, because that's how I name the form, and problem in lowercase as well. So I seem to be getting a piece of my metadata, so to speak, the column name, and not only the languages in question. So how can I fix this? Well, there's a bunch of ways to do this, but the simplest way is actually to use a function in Python that just says next reader, which essentially means skip the first line of this file. Just next, and move on to the second row instead. If I now run this command again, let me do Python of favorites.py, and just so I don't have to scroll through hundreds of lines of output, recall this cleverness in the Linux operating system whereby I can pipe the output of one command into the input of another command, like the command less. And as the name implies, this is going to show me less output from top to bottom. Let me go ahead and hit enter. And indeed, we see that the very first line of output here is Python now and not language. So a minor bug fix, if you will, but at least now gets the job done. So at this point, we have a program in Python. It's only a few lines long that seems to know how to open a CSV file, read it line by line by line, and I have the syntax in Python to access particular columns. Bracket 0 for timestamp, bracket 1 for language, bracket 2 for problem, even though here I'm clearly only playing around with the column number 1. Well, what might I want to do? Well, let me take a baby step toward making this program more interesting. Let me clear my terminal window for just a moment. Let me go into my for loop here, and instead of just all in one breath printing out row bracket 1, let me actually create a variable, just for the sake of discussion, called favorite, so the current favorite language, and just set that explicitly equal to row bracket 1, and then print that out as favorite. So I haven't fundamentally changed anything about this program. In fact, I've kind of introduced a seemingly unnecessary variable, but I just want to be pedantic here about how we can make this program even more user or programmer friendly to me. So this is still going to work. Let me go ahead and run again Python of favorites.py and pipe the output of that command into the input of less. And I again see the exact same input. But the reason I did this is because I want to improve this program now. It turns out that my program as written is a little vulnerable to changes in the CSV file. Like if you've used Google Sheets or Microsoft Excel, you probably know that you can click on those programs and drag to move the column to the left or to the right if you kind of want to reorder your data. And the problem with that is that if I or if a colleague of mine gives me a CSV file whose columns are now in a slightly different order, that's going to create a problem for my code, which is currently assuming that the favorite language is always in bracket 0. So the second column, the middle column among those three. But it'd be nice in general to make your code a little more robust against changes to the input so that things just don't break unbeknownst to you. So I'm actually going to introduce a different feature of the CSV package, whereby instead of using a reader, I'm going to actually use something called a dictionary reader or dict reader, which is going to give me back essentially not a sequence of lists, one per row, indexed by numbers, 0, 1, 2, but it's actually, this dict reader, going to give me back a dictionary, or dict, for each row, so that instead of using numeric indices like 0, 1, and 2, I can actually use strings as keys to get at the data that I actually want. Specifically, I can use the names of the columns as defined in that first row of the file. So let me go ahead now and make a couple of other changes. We no longer need to ignore the first row of the file. So I'm going to get rid of this call to next, because the dictionary reader is going to assume that the very first line of the CSV file has the header names that I care about, and it's going to consume that row for me automatically before iterating over everything thereafter. And the reason I introduced this favorite variable a moment ago is because I wanted to be super explicit here that instead now of indexing into the current row as though it's a list with numeric indices, I instead am going to index into this row using strings as my keys, using the syntax for indexing into a dictionary instead of a list. And for that, I can simply do this, language, quote unquote. So row, now to be clear, is no longer a list in Python. It's actually a dictionary, but I can still use the same square bracket notation to index into this dictionary, but this time using the proper name of the column. So now, if I go ahead and clear my terminal, rerun this same command, piping the output through less so we can just see the first few lines, voila, it's still working as intended. But if I now were to go back to Google Sheets or Microsoft Excel and futz with the graphical user interface and move those columns around, download a new CSV wherein there's still comma-separated values, but they're sort of in a different order, this code now will still work unless I or a colleague very difficultly, with great difficulty, changes the names of the column headers themselves, at which point things are still going to break. But at least now this is more robust against minor mistakes like reordering. Let's tighten this up again. I didn't strictly need that favorite variable, so let me go ahead and actually get rid of that and just more succinctly now print out row bracket, quote unquote, row bracket, I'm confusing the two, row, quote unquote, language to print out this current row's favorite language. So fairly straightforward there. But now let's actually solve a more interesting problem, because at the end of the day, all this program is doing is iterating over CSV, printing out all of the favorite languages. That's not really a step forward, because I could already see in Google Sheets itself all of the answers that I actually cared about just visually with my own eyes. But it'd be nice now to maybe crunch some numbers. And it'd be interesting to know, among the people that submitted this form in time before I downloaded it to my code space, how many people do prefer Scratch? How many people do prefer Python? How many people do prefer C? Well, it looked at a glance that Python was definitely visually the biggest contender, but let's quantify that now. So let me go ahead and make this program a little more interesting, whereby I'm still going to import the CSV package up here. I'm still going to open the file down here, and I'm still going to use my dictionary reader. But this time, instead of just blindly iterating over the file and printing things out, let's actually create a few variables. So one, let me create a variable called Scratch and set it equal to 0. Let me create a variable called C and set it equal to 0, and a variable called Python and set it equal to 0, so that I have 3 variables via which I can count how many people like Scratch, how many people like C, how many people like Python. Now, this is a little bulky visually, so stylistically, there's actually a slightly more elegant way to initialize multiple variables at once that I'm going to avail myself of here, just to make the point that I can. Scratch, comma, C, comma, Python equals 0, 0, 0. And there's other ways still to achieve the same goal, but this is just a little tighter. Instead of wasting 3 lines, I'm using 1 line to do exactly the same thing. This has nothing to do with CSVs. It's just a coincidence that I'm using commas on this line 5 to separate my variables and these values, but it's a Python trick if you want to initialize multiple values at once to a value like 0. Now, let's bring back that for loop. So for each row in that dictionary reader, row by row by row, let's go ahead and grab the current row's favorite language, as we did earlier. And now let's use some conditionals to check what that favorite is. So if that favorite equals quote unquote scratch, well, then let's go ahead and increment our scratch variable by 1. Else, if the favorite value equals C, then let's go ahead and increment our C variable by 1, just as with scratch. Else, if the favorite equals Python, then let's go ahead and increment our Python variable by 1 instead. Now, technically and logically, I could have just used an else at the bottom of this conditional, but just in case someone slipped in a 4th language that I don't want to talk about yet into the file, or maybe the form changed, but my code doesn't know about it, I don't want to mistake some random other value for Python, so I'm just going to ignore, logically, any rows that don't equal scratch or C or Python in this case. Now, at the bottom of this program, outside of that loop and outside of the file itself having been opened, which because of the width will be automatically closed now, let's just print out these 3 values. So let's print out, using, say, a format string, just so it looks a bit pretty on the screen, that the total value for scratch is going to be whatever is inside that scratch variable. Let's print out on the screen another format string that says whatever the value of the C variable is. That's how many people love C. And then lastly, let's print out another format string with Python as its prefix, and print out through interpolation there of the variable Python how many people really liked Python. So if I didn't make any mistakes here, I think I can reopen my terminal window now, run Python of favorites.py. I'm pretty sure that the most popular language, just based on a glance earlier, is going to be Python, but let's see if we can quantify it by hitting enter. And indeed, it looks like 11 of you like Scratch, 59 of you like C, but 243 of you prefer Python. So glad to see that it's only getting better and better, it would seem, here over the week. So how did we go about doing this? Well, very mechanically, right? I wrote a decent amount of code here, some 17 or so lines, just to iterate over that file, create some variables, increment them as needed. And this is totally fine. It's not an unreasonably long program, but I do think it's getting a little wordy, if you will. It seems like we're spending an awful lot of time sort of building this up, when it would be nice if we could maybe simplify this code a little bit, because this is kind of a common paradigm. You get some data set as input. Someone, maybe it's your teacher, maybe it's your boss, maybe it's your own curiosity or asking questions about that data, you'd like to provide answers. Well, how can we go about improving this kind of code and doing something a little differently? Well, let me propose that we revisit this idea of dictionaries themselves. They've already been useful in the context of this dictionary reader because we can get handed back more user-friendly dictionary objects instead of rows, each of which represents a row of our data. And recall that a dictionary really is just this. It's a set of key value pairs. And it's sort of the Swiss Army knife, if you will, of programming, because it's actually very powerful to just be able to associate one thing, a key, with another thing, a value. So in fact, instead of having, for instance, 3 separate variables just to keep track of all of those counts, why don't I draw some inspiration from the world of dictionaries and maybe use one dictionary to keep track of all 3 of those languages? And this has been the thematic. Way back in C, recall that we initially would often create 1, 2, or more variables, and then we realized, no, there must be a better way, and there was. In week 2, we introduced arrays, which allowed us to have one variable containing multiple similar values. And now with Python, because we have these full-fledged dictionary objects that's just to allow us to associate arbitrary keys with arbitrary values, we can use that a little more readily and keep our code a little cleaner too. So back here in VS Code, let me go ahead and propose that instead of having all three of these variables here, and in fact all of these conditionals here, let's get rid of most of that code in the loop, and instead let's just create a new variable, for instance called counts, that's going to be an empty dictionary. And recall that two curly braces open and close together with nothing inside in Python gives me an empty dictionary. Sort of a table that's ready to go, looks a little something like this, but with nothing in it initially. But it's now one and only one variable. All right, now let's go ahead and iterate for each row in that reader, just as before. Let's go ahead and grab the current row's favorite by using the dictionary we just got back from the reader, indexing into it via the column name language. And now, instead of having those three conditionals using three different variables, let's be a little more elegant. Let's just say that we should go into the counts dictionary, index into it at whatever this name of the language is, and increment that by 1. In other words, use the current language, Scratch or C or Python, as a key into the counts dictionary, and whatever its value already is, increment it by 1. Now this is close, but actually a little buggy. It turns out if you just blindly index into a dictionary using a key like Scratch or C or Python, but that key isn't yet there, that's actually a so-called key error. You can't just blindly use a key that doesn't yet exist and try to increment it, because what are you incrementing? There's no data actually there. There's no row in this table to go increment the value thereof. So I do need to be a little more careful here. Let me instead do this conditionally. So if the current favorite language is already in the dictionary called counts, then OK, go ahead and index into the counts dictionary using that favorite as your key and increment that value by 1. Else, if it is logically the case that that favorite language is not yet in the dictionary, that is to say, there is no key for it yet in this dictionary, OK, no big deal. Let's index into that dictionary, but assign it a value of 1. So if it's already there, well, then presumably we've seen it before, so we want to increment the total value. But if it's not yet there, we just want to assign it a value. So in both cases, we're indexing into the dictionary, but we have to make sure that we're only incrementing an existing value if it's there, but we're initializing the value to 1 for this current row's favorite language if we've not seen the same language before. Now, at the very bottom of this program, let me go ahead and get rid of all three of these printfs and just do something a little simpler. Let's go ahead and iterate over every favorite key in that counts dictionary. And again, this is sort of Pythonic syntax whereby you don't have to worry about what's the key, what the value is. If you just iterate over a dictionary using syntax like this, the favorite variable that I'm creating in this here for loop is going to be initialized to, 1 by 1, each and every key in that dictionary, presumably 3 in total, given the data we have. So inside of that loop, let me go ahead and print out a format string containing the name of the language, using curly braces to plug in that value, and then let's go ahead and output with another set of curly braces whatever the value is of that key by indexing into that dictionary inside of curly braces, and then closing the quote on the outside, which should give me language count, language count, language count by iterating over that dictionary. All right, crossing my fingers as always, let me reopen my terminal. Let me rerun Python of favorites.py, and voila, we get the same counts. Now, I will note they're slightly differently ordered. I think earlier we saw Scratch and then C and then Python, but in this case we're actually seeing Python and then C and then Scratch. And this is subtle, but does anyone have an instinct for why this is the case? Why did my ordering suddenly change now that I'm using a dictionary instead of 3 explicit print calls? It's ordered by default based on the order in which we inserted those keys. And so the answer actually lies in favorites.csv itself. If we go back to that file here, you'll see that someone's favorite language, as of the second row in this file, was Python. Though, curiously, their favorite problem was Scratch. So I'm not quite sure how to reconcile those two. But their favorite language, Python. The next person's favorite language was also Python. Oh, the third person's language was C. And then if we go down and down and down, I think we'll eventually see scratch. And so dictionaries nowadays are ordered in the sense that if you insert one key before another and then you iterate over that dictionary later, you're actually going to say the same ordering thereof. Whereas I previously in my code had full control over all three print statements. So it seems to be an opportunity for us to perhaps sort these via key or maybe even value. In fact, one is a little easier than the other. And let me go back into my favorites.py here and propose that we do that. Let's first sort by the counts themselves. So this is actually a relatively easy change. Down here in my for loop, instead of just blindly iterating over the dictionary from first key to last key, let's actually sort those counts first by using Python's sorted function. And then in my terminal window here, let me run Python of favorites.py again, enter, and now you'll see that I've actually sorted them by the keys themselves, C and Python, then Scratch. So it's not the same order in which I printed them. Now it seems to be doing it alphabetically, but I do seem to have some control over how I'm printing this here file. All right, but what if I actually want to be a little more clever and print these things out in order of their values, not their keys? So I don't really care about alphabetization. At the end of the day, I really want to know what's the most popular, what's the least popular. How can I go about doing this? Well, in my same code here, let me hide my terminal window for a moment. And let me add a bit more syntax to the sorted function in Python. It turns out if you want to do this, you can actually specify what key to use to sort the dictionary. And I'm going to use a clever trick here whereby I write key equals counts.get. And that's going to tell the sorted function that I actually want you to get the value from the counts dictionary and use that as your sorting key. So don't use the actual key in the dictionary as per our slide here. Instead, use as your key whatever the value is of the counts dictionary itself. So sort by count. Let's go now and open my terminal window again. Let me rerun favorites.py, and I'm going to leave the previous run on the screen so we can see now that this one, so close. So it's clearly not alphabetically sorted anymore, so that's good because I didn't care about alphabetization, but it seems to be sorted how? From smallest to largest, so from least favorite to most favorite. So that's kind of backwards, but not to worry. If you consult the documentation for Python's sorted function, you'll see actually that there's another argument we can provide to sort it. Let me clear my terminal here and close it for a moment. And let me say that, you know what? Whatever you do with sorting, go ahead ultimately and reverse it. So set reverse equal to true. Clearly, the default value must be implicitly false. But if I reverse that order by getting each count, now if I run Python, or Python. Now if I run Python of favorites.py, enter, now finally, all these minutes later, I have a proper analysis of everyone's favorite language ordered from most favorite to least favorite. The code itself, not terribly long, still 14 or so lines, but it's kind of a decent amount of effort just to get to this point. I had to write a decent amount of code, add a decent amount of complexity, just to get a simple answer. And you can imagine that. You glance at the Google form, or your boss glances over your shoulder and asks, what's everyone's most popular, what's everyone's favorite language? It'd be nice to be able to answer that super quickly. Ironically, just like Google can, just like Microsoft Excel can, just like Apple Numbers can, because typically you can sort of highlight the data, and then in the bottom right corner nowadays, you can see a quick summary maybe of the max value, the min value, the sum, the average, or you could use functions built into a spreadsheet. It almost seems like I have to make more work for myself in code, at least with Python, to answer those same kinds of questions. But not to worry. That's why we're introducing ultimately a new language today, SQL, via which we can actually get back that speed, that flexibility that you already get in graphical interfaces like spreadsheets, but you can also use that technique programmatically in code as well. A really good question, and we'll come full circle to the answer to that actually toward the end of today's lecture, because it's compelling to mix programming language. In fact, any number of purpose language, the equal signs here. So I don't have any equals in Scratch. In fact, we'll focus now to a proper database for this here data. And in fact, we'll focus today on what are generally called relational databases, which is a piece of software that allows you to store data, thus a database, but in such a way that you can relate some of your data to other data. In other words, instead of just throwing in all of this data messily into like a folder, much like on your Mac, your PC, or even your phone, you can actually store it a little more methodically, a little more algorithmically, if you will, by baking into the database some kinds of relationships among pieces of data. And we'll see in a moment what we mean by that. In fact, the language we'll talk about ultimately today, SQL, or SQL for short, really stands for Structured Query Language, which is a programming language specifically designed for databases. So once we've got a lot of data in a database, SQL makes it easier to get it back out. And in fact, among our goals now for the coming time together is going to be to see, can we take that 14-line program in Python and whittle it down maybe to 1 line of code in a different language, namely SQL here. So what does SQL allow us to do? Even though it's a new programming language, we're only going to spend today on it, really, as well as a problem set, though we'll use it again later in the course, too, to solve bigger and better problems as well. But it really only supports 4 key pieces of functionality that are sort of crudely referred to in the industry as CRUD. CRUD is a helpful mnemonic for keeping track of what you can do with SQL. And in particular, the C stands for create. You can create data in a database. The R stands for read. You can read or access data from the database. U for update, which means you can update or change data in the database. And D for delete. You can, of course, delete data from the database. So even though we're about to see a new programming language, at the end of the day, it really only does these 4 things. Now, technically, and a little confusingly, it literally does 3 of those 4 things using the exact same terminology: create, update, and delete. But it turns out CRUD is a more general concept in databases more generally. In SQL specifically, the command we're going to see and use for reading data, getting data from a database, is technically called select. And if I may, it turns out there's a couple more ways to create and delete data. You can also insert data, which starts with I, so it doesn't really fall into our nice acronym there. You can also drop data, or really drop whole sets of data or tables of data, using D for drop as well. So this is to say there's still only 4 fundamental operations, but the verbiage that we use throughout the language might vary from command to command. So what can we actually do with SQL? Well, first we need a database to start playing with. And the data in databases are stored in what we're going to call tables. And tables have rows and columns, which wonderfully is exactly the same mental model that we have in the world of spreadsheets. Whether you saw them today in CS50 for the first time, or have been using spreadsheets for years, whether it's Google's or Microsoft's or Apple's or anything else. Spreadsheets, of course, also store data in rows and columns. And if you have multiple sets of data inside the same file in the world of spreadsheets, recall that you can create multiple sheets. Now, in the world of relational databases that are used for web applications, mobile applications, business applications more generally, you can have an analog of exactly that same idea. In the world of relational databases, we call sets of data tables that have rows and columns, which is really the analog of sheets in the world of spreadsheets. And the command via which you can create such a table is not quite as simple as going to like the file menu and adding a new sheet or clicking a little plus icon somewhere. This is a programming language, SQL. So if you want to create a table, you're literally going to express code like this by typing it at a command prompt and hitting enter. But where are you going to actually run that? Well, it turns out that in the context of CS50.dev and our own VS Code environment, and really a standard practice in industry as well, would be to use a command line program to access a database. Specifically, we're going to use a database called SQLite, which, as the name implies, is sort of a lightweight version of SQL. That doesn't mean it's a toy language or a toy database. In fact, SQLite databases are used in web applications, mobile applications, and all of the CS50 applications we're going to build here. And what's nice about SQLite is that it stores all of your data in a file on your hard drive or a file in the cloud. It's not a special piece of software per se that needs to be installed and run 24/7, 365 so that you can constantly have access to the data. That is the case with databases like MySQL or Postgres or Oracle or Microsoft Access or SQL Server. There's so many SQL databases out there that are syntactically mostly the same, but certain databases have slightly different dialects, so to speak. They've sort of evolved slightly slightly differently over time. But we'll focus on SQLite, which really is not only light, but has a lot of the core features of any SQL database out there. So in fact, in the real world, if you start to use some other SQL database, you should be quite fine ultimately having this foundation in SQLite itself. Now, how do you use SQLite on, say, a Mac or PC or in VS Code in the cloud, as with CS50.dev? You just need to install the software, which we've done automatically in advance for you, and you can run a command line program called SQLite 3, where the 3 just represents the third version of this here program. So SQLite 3 is going to be a command line program via which we can create a database and also execute commands inside of that there database. The typical syntax for creating a new database with the SQLite 3 command is literally SQLite 3 space and the name of the database that you want to create. So in fact, let me go over to VS Code here, and let me go ahead and type SQLite 3. And then let's call this favorites.db. So there's different file extensions in the database world, but .db is pretty common in the world of SQLite for storing your actual database. When I
on a file.
Go ahead now and hit enter, it's going to ask me here in CS50.dev, are you sure you want to create this file? And that's just as a quick reminder that it doesn't exist yet, but that's indeed my intent. So Y for yes. And now I'm at a SQLite prompt. So notice it's no longer a $, which is my terminal window's default prompt. Now I'm inside of a program that's running continually until I quit out of it, and that prompt is SQLite and then an angled bracket, a greater than sign, just to indicate that I'm not in my terminal per se, my shell, but rather in this here program. Now, I could type some fairly arcane commands and import that whole CSV file into this .db file, but it turns out that SQLite 3 comes with some handy commands to just automatically import a CSV file for you. And what I'm going to do is this. I'm going to type first .mode, and I'm going to put SQLite into CSV mode. Long story short, SQLite can import different types of text files like CSVs, TSVs, tab-separated values, and other formats as well. But I know in advance that I want to import a CSV file, so I'm going to tell SQLite to go into CSV mode. The fact that I started this command with a dot is just specific to SQLite itself. It has nothing to do with SQL per se and the commands we're about to see and use, but anything that starts with a dot at the SQLite command just means you are configuring the SQLite program itself. Okay. Now, let's go ahead and import with .import favorites.csv into a table called favorites. So to be clear, I already have a file called favorites.csv. Okay. I've just created a new file called favorites.db. Okay. And I want to store inside of that DB file, the database, a table called favorites. So this is like having a sheet called favorites inside of a file called favorites.xlsx in the world of Microsoft Excel. I'm just naming everything accordingly. I'm going to go ahead and hit enter. It blinked for a moment, but didn't take very long. And now let me go ahead and just do .quit enter. And .quit gets me back to the $ prompt as usual. But now, if I type ls, not only will I see favorites.csv, favorites.py, but also now favorites.db, the database that I've just created and into which I've imported all of this data. Well, let me go ahead now and clear my terminal and rerun SQLite 3 on favorites.db, enter. That brings me back into the prompt. And let me now start to poke around. Like, what is it I just did by importing that CSV file into this database? Well, I can see as much by typing .schema, the schema of a database.
Well, hold up.
And let me know
so what
of this data.
So
.db, the database that I've just created and into which I've imported all of this data.
Hold up.
Everything accordingly. I'm going to go ahead and hit enter. It blinked for a moment, but didn't take very long. And now let me go ahead and just do .quit enter. And .quit gets me back to the $ prompt as usual. But now, if I type ls, not only will I see favorites.csv, favorites.py, but also now favorites.db, the database that I've just created and into which I've imported all of this data. Well, let me go ahead now and clear my terminal and rerun SQLite 3 on favorites.db, enter. That brings me back into the prompt. And let me now start to poke around. Like, what is it I just did by importing that CSV file into this database? Well, I can see as much by typing .schema. The schema of a database is the design of the database. What table or tables are in there. So if I do .schema enter, I'll see now some fairly arcane syntax, but this was all automatically done for me when I used the .import command. Apparently, what that import command did for me was execute an actual SQL command called create table, if not exists, quote unquote favorites, and then import into that table apparently 3 columns: a timestamp column, a language column, and a problem column. And those are all encased in parentheses here. They are all quoted as you see, and they're separated by commas. Again, these are now these are SQL commas, not in the file itself. But what type of data did I import? Well, the .import command is pretty naive, and if it just sees data, it's just going to assume it's text, text, text. So even if it looks like numbers, it might still assume that it's just text, 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 but we're going to get back to that. In the world of SQL, there's actually going to be proper data types we can do. So long story short, what was the point of this? Well, I didn't want to first start our introduction to SQL by typing out this cryptic-looking command and then manually import all of that data. The .import command just automatically gets me going with a SQLite database containing all of the same data as a CSV. And frankly, you could imagine doing this in the real world. If for work or some future assignment, you've got a CSV file that's part of the assignment or task, you can very quickly import it into your very own SQLite database and instantly start executing the following types of SQL commands on it to answer questions about that data. So let's do exactly that. Let me clear my terminal, but stay inside of SQLite. Okay. Let me increase the size of my terminal, just because we're going to start to see a lot of textual output. And let me propose that we introduce the first of those CRUD commands via which we can start to read data from a database. Recall that the first command, recall that the command for reading data from a database is this, select. So it kind of has the right semantics. When you want to select data from a database, read data from a database, you literally write select. And then you specify one or more columns that you want to select data from, and you specify from what table you want those columns to come from. So what you see here on the screen is sort of the canonical, simplest form of the select statement in SQL. So let's put this to the task. Let me go back to VS Code here, where I have my full screen terminal window, and let's select everything from this favorites table. Let me go ahead and type literally select star, where star in this case is a wildcard representing every column that happens to be in the table. From what table? Well, the favorites table, semicolon. So you do need to, unfortunately, end your SQL thoughts with semicolons, just like in C, but unlike in Python. Now, this is a quick and dirty command, so to speak, in that it's really just going to dump out all of the data onto the screen for me. But when you're opening a database for the very first time, it's kind of a nice, simple way to get started if you just want to wrap your mind around what is it I just opened, kind of like glancing at a file on the screen. So I'm going to go ahead and hit Enter. And very quickly, you see a sort of ASCII art version of that tabular data. So the commas have been interpreted in advance as being delineating different columns. That's why visually we see on the screen these sort of vertical columns or pipes, and that's just SQLite being user-friendly for me. In fact, if I go up to the very top of this output here, you'll see that immediately below my command, I see 3 columns named timestamp, language, problem. So that CSV has been somehow loaded into memory in this 3-column format. Now, suppose I don't really care about timestamp, and for now I don't even care about problems. What more can I do? Well, let me clear my screen and let me select a specific column. So select only the language column from the favorites. And if I now hit semicolon and enter, now I get back essentially a single column table, a subset of that there table. And in fact, that's what I'm doing with each of these commands. I'm sort of creating temporarily in memory a virtual table that just contains the data that I care about. And I'm not doing anything useful with it yet. I'm just dumping it to the screen. But I am essentially selecting these temporary tables with these various commands. Now, this isn't all that much progress, just looking at the very data that I've always had access to. But besides just selecting the data, turns out that SQL, like Python, like C, like Scratch, comes with a whole bunch of functions built in. A lot of these are mathematical or statistical or analytical in nature. And indeed, SQL is very commonly used in the world of data science and analyzing data, consulting, and the like, because it lets you very readily, as you'll see, answer questions about data. And for instance, you might want to compute averages, or AVG for short. You might want to count the number of rows in some data sets. You might want to get unique or distinct values values from a data set. You might want to force everything to lowercase or uppercase. You might want to get the max value, the min value, and that should evoke recollections of the exercise we just did with trying to find the most popular language in that their data set. So for instance, let me go back to VS Code here, and let's try a couple of these out. In my SQLite prompt, why don't I go ahead and just see how many people submitted this form before I downloaded it into my code space. So I can do, of course, select star from favorites, semicolon, and I could just manually, visually count all of the rows. Like there's got to be a better way when there's hundreds of them, and indeed there is. Per this list of some of SQL's functions, I can use the count function to answer just this. Now, I don't really care what I count. I really just want to count all of the rows. And so the best way to do that is to actually say, canonically, select count star, using the star in parentheses, because count is a function, so I'm passing in arguments. And star, again, is a wildcard that represents all of the columns. And that's fine, because I just want to count the total number of rows ultimately. So from favorites, semicolon. And what I'll now get back is not all of the darn data in the table, but rather a single temporary table that contains just one value of interest. 313 form submissions came in before I closed it and downloaded that file. Now, I made the form, so I know what the candidates for favorite languages are, but there's other things I can do with this data too. For instance, if I want to get the unique values of everyone's favorite language, well, I can use distinct as a keyword here too. This one I actually don't need parentheses for, it turns out, but I'm going to do it here as follows. Select all distinct languages from the favorites table. And this is going to now whittle down that long column of all of the languages that everyone selected into just a list of 3. Because, of course, there's a lot of duplicate Pythons. There's a lot of duplicate Cs. There's a few duplicate Scratches. Distinct just means I only care about the distinct values of language. Now, what if you want to count how many unique languages there are? We can compose these ideas in the same kind of way as in Python and C. I can do select the count of all of the distinct languages from the favorites table. So again, I'm first filtering it down to the distinct languages, then I'm counting those rows from the favorites table, and as you might expect, I get back 3 as my answer. So sort of little tiny bite-sized questions I'm asking, but all very quick and all just with a single line of code. So even though I have the power now of programming, I can still answer questions like my familiar spreadsheet tools long have. But it gets a little more interesting than this. It turns out there's yet other features besides these here functions, and there's some other keywords we can use. And we'll just start to scratch the surface of these to give you representative use cases of these. But it turns out that you can group data. You can look for data that's like a certain value, not exactly equal to. You can limit how much data comes back if you're getting overwhelmed with the number of rows. You can order or sort the data, and you can also use essentially conditionals, filters, otherwise known as predicates, to get back just subsets of data instead. So for instance, let me go back to VS Code once more, and let me play around with a few of these new keywords, and let me propose this. Suppose I care about how many of you really liked C. Well, I could just select all of the data as before and sort of count it up manually, but that seems unnecessary. Let me do this. Let me go ahead and select the number of people who, from favorites, where the language they gave us an answer to their form was equal to quote unquote C. And you'll notice this is the first time I'm using literal quotes. In SQLite, when you want to quote a string value, a textual value, a literal, you use single quotes. And I realize all of these languages have their own conventions, but in SQLite, you would use single quotes around values like C. So what is this asking? This is saying select the count of all of the rows from favorites where the language in that row happens to equal quote unquote C. So this should give me the same number as earlier in code, and indeed, there's that same count, 59. But how did I get it? Notice that I was able to answer this in 1 line of SQL code as opposed to 14 or so lines of Python code. All right, what else might I do? Suppose I want to be a little more specific, and I really want to know how many people liked not only C, but Hello World, right? They sort of peaked early in terms of their excitement and really liked Hello World, and then none of the problems since. So how can we express that? Well, let's go ahead and select the count of all of the rows from the favorites table where their favorite language is quote unquote C, and the problem that they love is quote unquote hello, comma, world. That was one of our very first problem sets in C. And so now I'm using this conjunction of checking for the language value and the problem value. Similar to Python, the keyword is indeed and, unlike C where it was ampersand, ampersand. But this is now giving me some Boolean logic. If I go ahead and enter, we'll see that 8 of you, OK, I'm not sure how I feel about that, 8 of you really liked not only C, but hello world was your favorite problem in question. But we can get back that answer, too, with just one line of code. We don't have to write a whole Python program. We don't have to debug it. We can just express ourselves in a new way using this here language known as SQL. What, though, have I been doing very carefully stylistically? You'll notice that I keep capitalizing select and count and from and where and then using lowercase as appropriate for everything else. This is a stylistic convention. We've talked about style, of course, in the context of C and Python quite a bit. In general, in SQL, we would encourage you stylistically in CS50, and really in the real world, use uppercase keywords like select and count and from and so forth for anything that's built into SQL itself. And then use the proper capitalization for any tables you yourself have created, for any values that you're searching from. Why? Well, frankly, it just tends to be a little more readable when you can distinguish what is SQL code and what is actual table names and values therein. But this isn't a universal thing. Even different databases and different programmers might have their own conventions. So let me pause here and see, thus far, are there any questions on our use of SQL with any of these keywords here or our prior ones? What is the difference between select and insert? Select is just for getting data or reading data. Insert is going to be for adding new data. We haven't gotten there yet, but we will shortly. So distinct gives you back unique values. Group by we'll get to in a moment. But distinct, we've seen, gives you unique values. Oh, can you chain the commands together? You can separate the commands with semicolons, just as in Linux. But generally, I would say people do them one at a time. We'll see in a moment how you can nest queries, though, as well. A good question. Does it matter if you use single quotes or double quotes? The right way to do it in SQLite is indeed with single quotes. That is the convention. However, SQLite has been around for a while and is very tolerant of different conventions. So it will often work to use different quotes, like double quotes as well. It even supports backticks in some cases. But what we'll try to show you here is sort of the right way to do things in general. And in fact, you'll notice that I'm actually not using quotes around everything. Strictly speaking, it's conventional in SQLite to use double quotes around keywords like favorites and language and problem, because those are symbols that I myself created in my database and in my database table. However, when there is not a corresponding SQL command that is identically named, it's not strictly necessary to quote values. So this is to say I could, to be really proper, do select count star from favorites where language equals quote unquote C and problem equals quote unquote hello world. And again, notice I've used single quotes for my string literals for the values I'm searching for, but I've used double quotes around all of the symbols from my table name and my column names. This is the right way to do this here. But I would say in the real world, it's so much more convenient to omit quotation marks when you don't strictly need them. So that's the habit that I will generally be in as well. All right, if I may, let me propose that besides these commands, we introduce a few other pieces of functionality and then improve on our database as well. So let me propose that suppose that I care about not just the hello world problem, but there was a follow-on problem, recall, in C, where it was hello, it's me, whereby you could actually type in and see your own name printed. So if I want to check for either of those, how can I express that logically? Well, it's very similar to Python and pretty similar to C. Select the count of the rows from the favorites table, where, as before, language equals quote unquote C, but now I want to check for two possible favorite programs. So let me use some parentheses logically, just like you might use in Python or C, where the problem equals quote unquote hello, comma, world, or, and I'm capitalizing it to make clear that it's a SQL keyword, the problem equals quote unquote hello, it's me, close quote, close parenthesis, semicolon. But before I hit enter, let me see if anyone can spot the potential bug in this code. I think I've just created a problem for myself by advocating for one style or another. The problem is that we seem to have, for my hello, it's me problem, there's actually 3 single quotes involved, one of which I'm using as an apostrophe for it. And this is going to be problematic because just like in Python, just like in C, the language, the computer is not going to really understand where the string begins and ends if there's this ambiguity. Now in C, and also to some extent in Python, the way we generally solved confusion like this is we would escape the value using backslash. In SQL, it turns out that you don't just put a backslash in front of the apostrophe in this case to avoid that problem. Weirdly and admittedly confusingly, the convention is to actually use 2 apostrophes. So this does not create one string on the left and one string on the right. Having 2 single quotes in a row means you only want one of them logically to be there. So this assuages that concern there. So if I now go to the end of my command and hit enter, this time it worked because now it turns out that 8 of you liked hello world. I'm inferring that none of you liked hello it's me any better because the count is still 8. But at least now if we get more data over time and I update the CSV and in turn my database, I would be checking for both the language of C and either the problem hello world or hello, it's me. But really the goal here has been to experiment with some of the slightly different syntax that we need to express some of these here problems. But you know what? What if I wanted to express this even more succinctly and I really just care about any of the hello problems themselves, be it hello world or hello, it's me? Let me propose to use one other keyword that's on our new list here, namely like, where you want to search for not necessarily something that's exactly the same, but like a value, so to speak. So let me go back to VS Code here, and let me do, as before, select count star from favorites where language equals quote unquote C, and here's the new part, the problem is not equal to, but rather like the following value, hello, comma, something. Now, how do I express something? Well, here there's another piece of syntax that we need to introduce. We've seen the asterisk or the star being used with count and in other contexts for selecting any number of selecting all of the columns available. But when you use the like keyword, if you want a wildcard, you actually use, a little weirdly, a % sign instead. So if I now do hello, comma, space %, in this context of using the like keyword, SQL will now search for all of the problems that start with HELLO, comma, space, and then 0 or more other characters after that. And because I'm being a little clever here, I know that both of the problems I care about are start with hello, comma, something. This should be equivalent to the previous command, but I don't need to have a special list of all of the values I'm looking for. This will get everything that starts with hello, comma, space. And indeed, I still get back my 8 rows as before. All right, how now might we use some of these other commands too? Well, it turns out that with group by, we can actually group similar values together. So how might this be useful? Well, consider this sample table here. It doesn't have nearly as many rows, but I propose that suppose I collected a small number of form submissions that just had maybe these 6 submissions. 1 person liked C, 3 people liked Python, and 2 people liked SQL. Well, we haven't yet seen syntax via which we could replicate that earlier Python program, whereby I really want to be able to get a quick analysis of how many people like C, how many people like Python, how many people like SQL. Obviously, I can just skim the list visually here because it's short, but if there's hundreds of submissions, let alone thousands or millions, it would be nice to be able to answer that question without having to write a dozen or more lines of Python code for a relatively simple and pretty common question. So how might I do this? Well, let me go back to VS Code and let me introduce that group by syntax. Let me go ahead and select the language column and the count for that language from the favorites table. But how do I want to do this counting? Well, let's go ahead and group those rows by the language value. So the only thing that's new here now is group by language. And what this is going to do for me is the following. If I go back to this here visualization, notice that the possible values are C, Python, and SQL, but there's several of Python and SQL. So how might I go about analyzing this? Well, really notice there's one value for C. there's these 3 values for Python, and there's these 2 values for SQL. Wouldn't it be nice, in kind of your mind's eye, you could take this table and kind of squish it vertically, grouping all of these similar values together. Combine all of the C values, all of the Python values, and all of the SQL values, as we've now left scratch behind. Well, how can I do that? What I really want is to get back an answer like this. I do want the count of something, but I want to group that counting by the specific value for language. I don't want to count up all of the rows as I keep doing. I want to group my counts by the value in the language column. So how might I express this with exactly this code? If I want to get back a 2-column temporary table, language in the left column, the count thereof in the right column, but I want to squish this together in my mind's eye and combine all of the similar languages together and then count those, I do, at the end of this query, group by language. And if I hit enter now, I get back that same analysis as earlier that we implemented in Python, but using a single line now of SQL code. How might I improve on this further? Well, notice here that currently what I've just selected is indeed the counts, really in the order seen here. C, and then Python, then Scratch, which seems to be alphabetized in this particular case. But it would be nice, frankly, if I could actually sort this by count. Not so much because I have a lot of data here, but if you had lots of different values in a much taller table, it might not be as obvious which is the biggest, so it would be nice to just do the sorting ourselves. So how might I do this? Well, let me go ahead and do a similar query, and just as in Linux, in your terminal window, in SQLite, you can actually hit the up arrow and go back through your recent commands. So I'll start to do that now to save myself some identical keystrokes. Let me go ahead and, instead of just ending my thought with a semicolon, let me actually say order by the count of those rows, semicolon. If I hit enter now, you'll see the exact same data, but it is indeed sorted by the count column. Unfortunately, just like with my earlier Python program, I accidentally sorted it backwards. It's from smallest to largest by default. In fact, what's implicitly happening here is that I'm ordering it by count in ascending order, ASC for short, whereby ASC indicates ascending order, so from smallest to largest. But if what I want to do is actually do this in descending order, I can actually do DESC for descending, hit enter here, and now I actually do get a sorting version of this from largest to smallest. With my earlier, let me actually, you had lots of different values in a much taller table, it might not be as obvious which is the biggest, so it would be nice to just do the sorting ourselves. So how might I do this? Well, let me go ahead and do a similar query, and just as in Linux, in your terminal window, in SQLite, you can actually hit the up arrow and go back through your recent commands. So I'll start to do that now to save myself some identical keystrokes. Let me go ahead and, instead of just ending my thought with a semicolon, let me actually say order by the count of those rows, semicolon. If I hit enter now, you'll see the exact same data, but it is indeed sorted by the count column. Unfortunately, just like with my earlier Python program, I accidentally sorted it backwards. It's from smallest to largest by default. In fact, what's implicitly happening here is that I'm ordering it by count in ascending order, ASC for short, whereby ASC indicates ascending order, so from smallest to largest. But if what I want to do is actually do this in descending order, I can actually do DESC for descending, hit enter here, and now I actually do get a sorting version of this from largest to smallest instead. Now, this temporary table I have here is a little weird because one column's called language, the other column's called count star. Turns out there's another trick we can use in the context of SQL if we actually want to rename these columns that we're getting back from our queries. And we can alias these things in the following way. Let me go ahead and now do this. Select language, comma, count star. But if I want to give this count star column an alias, a nickname, n is our go-to value for numbers, for instance, in programming. So let me rename this from count star to just n for number. And then let's do this as before from favorites. Let's group by language, and let's order by, and now this might make a little more sense. Let's order by n in descending order, semicolon. And now I get really back the same result, but I indeed see language as the column name at left, N for the column name it writes, and that's just a little more explicable. And in fact, this will be useful in code if you want to give aliases to the headers you're getting back, so that in Python or some other language, you don't have to keep typing count star. You can use nicknames or these synonyms instead. And just to show you one other query, one other keyword that flashed before our eyes earlier, there's also this limit keyword, which isn't super useful with this relatively small data set. But if you've got hundreds, thousands, millions of rows, you might want to limit the results to be just the top 10 or the top 1, because you might not care about all of the other data. Well, I can do that here in SQLite as well. Let me go ahead and clear my screen. Let me go hit up so as to open up the previous command. And let me add to the end of this statement limit 1 if what I really care about this whole time is what is everyone's most popular language. Enter. Now I get back just that answer. Okay. And there we have it. The most popular language with a total of 243 favorites is indeed Python. To be fair, our queries have gotten a little longer, but by just using these building blocks and those we've seen prior, we can express in really single lines of code what previously took us half a dozen or a dozen or more lines of code in, say, Python. Yes, a really good question. Unfortunately, yes. And I think as you're getting started with SQL for the very first time, like that's going to be one of the mistakes you and I commonly make by just getting things out of order. So I've been very careful with my cheat sheet to do things in the correct order, but even I forget sometimes and have to look it up or ask CS50's duck or the like.
Import both the selected and non-selected answers from Google Form responses.
A really good question. Short answer, no, because the way the Google form was designed was to only store values in the CSV if those options were selected. If no one liked a certain problem or even a certain language, we would have no evidence thereof. We would have to go back to the original form and maybe create a new table that contains all of the original authoritative answers, but that have nothing to do with what people selected. So indeed, as you'll see in Python, you might want to even validate data. There's probably some hackish ways where a malicious user could submit data into the form that wasn't actually on the form, unless Google too is doing validation. So that's a compelling use case for exactly that same solution.
Parentheses.
A really good question. So I'm following the same paradigm in mathematics, whereby if you are doing like multiplication followed by addition, and you want the addition to happen first between two values, you have to parenthesize that in math. Similarly here, what I cared about logically was that the language was C, and the problem was hello this or hello that. And so I expressed with parentheses the fact that I only cared about one of those latter being true, but I definitely wanted language to be true. And so parenthesizing in that way ensures that the operators are handled in the priority I intend.
If we were looking for a string like hello, how would you like and the wildcard in this case?
So in the case of the form I created, there were only specific values allowed. Hello, comma, world, and hello, comma, it's me. Names were not supported in the list of options I gave to the user. So I don't think this is a concern in my analysis of that data, because I know from the get-go what those values are. Even that said, if I were to use that like expression, hello, comma, space, %sign, if there were a third, if there was a fourth, if there were a fifth option in that form that started with hello, comma, something, we would also take those into account. So that might be a little too overly generous and indeed not the best design. Well, before we move away from this favorites data set, allow me to propose that we look at just a few other features before graduating to a real world, much larger data set as well. So in addition to being able to create a table, which we automated earlier, and in addition to selecting data, as we just did hands-on, you can indeed insert data into a table as well. This wasn't relevant in the case of our Google form because you all used a Google form to insert that data. But before long, I bet we're going to be writing software, wink, wink, whereby we're going to programmatically, in code, need to insert more and more and more data based on what someone maybe types into a form of our own. The canonical syntax for insertion is indeed this, whereby I can insert into the table name, and then in parentheses I specify one or more columns for which I have values. Then I literally say values, and then in another set of parentheses I specify one or more values that I want to insert respectively into those columns from left to right. So the syntax here is a bit more verbose, but let's go ahead and try this out. Let me go ahead in my VS Code and go and type insert into the favorites table. How about just the language column and the problem column? I don't really care about the timestamp. I don't want to figure out what time it is now and write it in the right format. So I'm only going to insert 2
on the language
values, not 3, specifically language and problem. The values I want to insert are going to be quote-unquote SQL, because I'm a big fan of SQL all of a sudden. And the value for problem is going to be 50vil, a problem that awaits you as well. Then I'll hit semicolon enter, and nothing seems to happen. But if I quickly do select star from favorites, which again is a nice quick and dirty command for just seeing all of the data in a table, look at the bottom of the table, I actually do see a new value, namely SQL and 50vil. Now curiously, there is a value for timestamp, but it's a special value, and we've seen this value by name before in C, that of null. So in the world of C, recall that null with 2 L's represented a 0 pointer, an invalid pointer, or just an initialized value that has no valid address. In SQL, this has nothing to do with pointers per se, but we still use null in all caps, null, to represent explicitly the absence of a value. And this is actually a really nice feature of SQL. Imagine the world of Google Sheets, Apple Numbers, Microsoft Excel. Humans make a mess of their data all the time. For instance, if you don't have a value in a cell, one of those rectangular boxes in a spreadsheet, does that mean it's deliberately blank? Does it mean you don't know the value? Does it mean you're missing it and you're going to come back later? So what do we humans do? Well, in English, we might have a convention like writing n/a for not available, maybe lowercase, maybe uppercase. But that's a complete hack, because what if you want the cell to actually contain, for whatever reason, n/a? It's ambiguous. So maybe you color it in a different color, like maybe black it out in the spreadsheet just to indicate, no, there's nothing here. But a color is not an explicit value for a cell. So in the world of spreadsheets, it's actually harder to express the deliberate absence of data than it is here in SQL. So when you have a null value, that means I or someone has made a conscious choice to not put a value there. It is not the same as quote unquote nothing, the so-called empty string. It's not a blank value. It is the conscious, deliberate absence of a value instead. So that there is a plus. Now suppose I want to actually get rid of something now. Turns out there's other features indeed of SQL we should explore, not just the insertion of data, but the deletion of data as well. Now this one is pretty simple. Delete from table where some condition is true. But anytime, as in the real world, you can make really bad decisions and make really big mistakes by deleting data that you did not intend. So for instance, let me go back to VS Code here, and let me propose that I want to get rid of this SQL value because it wasn't in the original form. I'm really just playing around here. I can start my query with delete from favorites. And please, 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 especially if working as an intern or a full-time engineer in industry, do not ever end this thought with semicolon unless you know what you're doing. Because if I were to hit enter on my keyboard now, this is how you would delete everything from the favorites table. This has happened before. There are news articles about employees doing really bad things because they deleted data they shouldn't have. So let me just delete my semicolon and finish this thought, as per this slide where I'm saying you should really use a where condition. We used where before for select, where we only wanted to get a subset of data. Presumably when deleting stuff, I probably only want to delete a subset of my data, maybe one row or a few, hopefully not ever all. So let me specifically delete from favorites where the timestamp column, capital T, because that's how Google does it, is null. And this too is a little weird. Instead of saying equals null, the right way in SQL is to say is null, or conversely is not null, to express that you literally are checking for that absence of a value. So this I'm more OK with, because I know that all but one of my rows has timestamps. So if I hit enter now, nothing seems to happen. But if I do select star from favorites, semicolon, enter, notice the bottom of my output no longer has that SQL or 50vil value. Now, I will say there's other things too we can do with our data set, not just insert, not just delete, but also update existing values. And this syntax is a little wordier, but it does what it says. If you want to update a table and set one column equal to some value where some condition is true, you can express that with code like this. You can actually set multiple values at once by separating column equals value, comma, column equals value, comma, column equals value, and so forth. But for now, I'm going to go ahead and set two things to known values. Suppose that I'm really getting excited about SQL. I really hear good things about this 50vil problem. Let's kind of change this data and decree that everyone's favorite language as of today or this coming week is going to be SQL, and their favorite problem is going to be 50vil. So I can do this, albeit destructively. Update favorites, set everyone's language equal to SQL, and everyone's problem equal to, quote unquote, 50vil, semicolon. I haven't executed this yet, but what this means is that it's going to iterate over the table, top to bottom, and because there is no where clause, I am going to change every cell to equal SQL and 50vil, respectively, in the language and problem column. So this, too, probably not something you should do in the real world, certainly not when working for a real-world company with a real-world database, unless you want to blow away all of your data and replace it with SQL and 50vil. But let's do that. Enter. Nothing seems to have gone wrong. Let me do another select star from favorites. And I really hope no one has questions about the previous version of the data set, because now everyone loves SQL and 50vil. And unlike most computer software, I cannot just hit Control or Command Z to undo. What you have to do now is exit out of SQLite, hope you made a backup of your database earlier, which I didn't, and then restore somehow from backup. So beware the power of these commands that you now have at your disposal. All right, so that was a lot, and unfortunately we're out of data now, the hundreds of rows that we've had, but that was never a lot of data to begin with. So in fact, let's go ahead here and take a few minutes break, and when we come back, we're going to graduate from hundreds of rows to millions of rows of data. Indeed, we're going to introduce you to a real-world data set known as IMDb, the Internet Movie Database, which has lots and lots of information about movie stars, movies, and TV shows, and so much more. And we're going to use some of that publicly available data to explore SQL all the more, but also the design of our databases. But let's come back in 10 minutes, and we'll pick up there with millions of rows suddenly.
All right, sweet. So that will wrap up the lecture portion